Math 3, Unit 6, Section 4. Today we're talking about multiplying and dividing radical expressions. And so previously we talked about multiplying by the conjugate, and we are going to be using that later today. But we also need just to be able to multiply these radical expressions. So we can continue to use the distributive property. Does that work for everyone, or you guys want me to show you the box method? Distributive property is good? Okay, so all we're doing is distributing. So we're taking the 3. 3 times 2 is 6. Okay, and so when we go 3 times 4 root 5, if you need to, write it to the side of your paper if it's easier for you to see that way. And so 3 times 4 root 5, the 3 and the 4 multiply together because they're both not under roots, and so you get a positive 12 root 5. Okay, when I go to the next term here, again, you can write it to the side. I have 2 times 2 root 5. And again, any number that's not under the root gets multiplied together, and then roots get multiplied together. And so we end up with 4 root 5, because 2 times 2 is 4. Okay, and then this last one, I have 2 root 5 times 4 root 5. And so we would multiply 2 times 4, because those are both not under roots, and then root, and I have 5 times 5. Well, what happens with the 5s? Very good. It makes a group of numbers, and they just become a 5. And so I end up with 2 times 4, which is 8, times 5, which is 40. So it might take like an extra minute to write it to the side, but until you're comfortable, it might make more sense to just kind of write those out so you can see exactly what's happening. And then now you're just going to combine any like terms that you have. And so we can see here that we have 6 and 40, which makes 46. And you normally write the number in front, and then the number with the other root goes at the end. And so we have 12 root 5 and 4 root 5, which would add to be what? 16 root 5. Good. And remember, the only way we can add those together is if they both have the same roots. And so since they do, we can add them together. Okay. Questions? All right, the next one, this one says root 7 plus root 3 squared. And so what that actually means is root 7 plus root 3 times root 7 plus root 3. Are those conjugates? What makes two terms conjugates? The signs are changed, but these are the same signs. So are these conjugates? No. And so we're probably not going to eliminate all of the roots, okay? So we're just going to do what we did previously. And so we're going to go root 7 times root 7. So on the side, I'm going to go root 7 times 7, because both of those are under a root. That makes a pair, which is going to make that what? 7. Okay, next we have root 7 times root 3, and so those would both go under. Can that make any groups there? Nope, and so that's just going to be what? 7 times 3 is root 21. Very good. Okay, now going to root 3, we're going to go root 3 times 7. Okay, again, no pairs, so that's going to make a root 21. And then the last one, we have root 3 times root 3. Okay, that does make a pair, so that ends up becoming just 3. Okay, and then all we do is combine our like terms. And so I have 7 and 3, which makes 10. And then root 21 and root 21, those, if they don't have a number in front, they have a number what? 1. So this is really saying 1 root 21 plus 1 root 21, which makes 2 root 21. Please focus. Okay, questions? All right, so on this next one, what do you notice about it? There's some variables, right? But we just treat them the same way as numbers. So again, we're just going to distribute. So we have 3 root 7 times 2 root 7, which means I'm going to multiply the 3 times the 2 together, and then both of the roots get to be multiplied together, which ends up giving me a pair of 7s. Good. And 3 times 2 makes 6, and then 6 times 7 is 42. Very good. Okay, next we have 3 root 7 times negative root x. So first of all, that's going to make a negative. And then, because a negative times a positive is a negative. And then we have 3 root 7 times x. Are there any pairs there? No. So that's just negative 3 root 7x. Okay, so next we have negative root x times 2 root 7. That will make a negative 2, and then we have root x times 7, which will just make what? Negative 2 root 7x, because there's no pairs, nothing I can break down. And then lastly, I have negative root x times negative root x, and a negative times a negative makes a positive. We have root, and I have an x times x, which makes a, very good, a pair, which is just x. And if you go back and look at the instructions here, it says assume all variables represent positive real numbers, which means we don't have to worry about absolute values. Okay? And so we just have plus x here at the end. So now we're going to combine like terms. When I go through here, 42, are there any other whole numbers that match? Nope. So we just have 42. And then I have this negative 3 root 7x and a negative 2 root 7x, and that would make what? Very good. Negative 5 root 7x. And then lastly, I just have plus x. Okay. Any questions? All right, this last one I'm going to have you try on your own. But I'm going to start you with this first one. So here you have root 30 times root 6. So root 30 times 6. Previously, they didn't have anything we could group, but on this one, do we have stuff we could group? Can 30 break down? Yes. What does 30 break down to? Good. 5 times 6. And I would stop there because you see how we have a pair of 6s right now? And so this is 6 root 5. Okay, so I'm going to have you go ahead and work through and finish this one on your own. And then I'm going to end up probably pulling some names for this one. Okay, anybody need more time? Yes, a few of you. Okay. Did anybody notice anything interesting about this one? Yeah, nothing combines. There are no like terms when you finish. Yeah. I know, so it makes you think you did something wrong, but that's just the way it is sometimes. Okay, so I'm going to go ahead and get started, but if I call your name, you are just going to help me work through one little piece, okay? So, this next thing I'm going to do is take root 30, and we're going to end up multiplying it times root 5, okay? So I want this person to help me with that. Nathaniel. I know, aren't you excited?
So, wait, the second part?
Yeah, so we already did the root 30 times root 6, so now we're going to go root 30 times root 5.
Alright, so you're going to do the same thing you did with the top 30.
Good.
And then this time it would be 5 and 6.
Very good. And so again, this still breaks down to 6 times 5 or 5 times 6, pair of 5s, and so we get 5 root 6. Nicely done. Thank you. Okay, so next one, now we're taking the negative root 3. Okay, so help me out with this. Riley.
I actually got stuck on this part because I didn't know if you multiplying.
So that's what we're doing. We're multiplying everything, okay? And so you're taking the negative root 3 times root 6. So we're just distributing to every single term, okay? So what is a negative times a positive? A negative, good. And then we're just going to write it out because there's nothing in front of the roots. So whatever's under the roots, we're multiplying those together. And it's easiest to just write it as 3 times 6 to check to see if it'll break down and if we can have any pairs. So can 3 or 6 break down? 6 can. And what does 6 break down to? Very good. 3 and 2. And so what do you notice there, Riley? Very good. A group of what? 3s. And we have a 2 left over. And so how do you write that? Close. So remember, yeah, good. So your group goes out, and so it's negative 3 root 2. Okay, and so the last thing I have left to multiply now is this negative the root 3 times root 5. And so I would like Jared to help me out with this one.
So you like put them under the thing?
Okay.
You like root thing?
Good, the root, okay.
And neither of them break down, so you just multiply them and you get root 15.
Okay, is it positive or negative?
Negative.
Very good, because a negative times a positive makes a negative. Very good. And so we write negative root 15. And then if we look at each of these roots, well, each of them are square roots. This is a root 5, this is a root 6, this is a root 2, this is a root 15, and none of them can break down to take out any pairs. So we have no like terms, and this is my answer. Okay, any questions? All right. So reading this paragraph, it says sometimes the denominator is a sum or difference involving radicals. If the radical expressions are square roots, you can rationalize the denominator by multiplying the numerator and the denominator by the conjugate of the denominator. Because we know that when we multiply by the conjugate, it eliminates the roots, correct? And we cannot have roots in our denominators. So, again, we're assuming all variables are positive, which makes it nice. And so in order to get rid of this root in the denominator, I first of all would put parentheses around it, because remember how if anything is adding or subtracting, it's connected like glue, right? And so I can't reduce anything unless it has a, you know, something exactly the same. The only way to get rid of this 7 minus root 10 is by multiplying by the conjugate. Okay, and what would be the conjugate for this? Very good, 7 plus root 10. And whatever we do to the bottom, we also have to do to the top. Okay, now there is a shortcut, but I'm not going to teach it to you guys. If you end up figuring it out, you can share it. But for right now, because I think some of you are still struggling with the multiplying part, we're just going to keep doing it the long way until we understand it, and maybe a shortcut, you'll see it. Okay? So, 7 times 7 makes what? 49. I'm just going to kind of write this to the side. Okay? 7 times root 10 is what? A positive 7 root 10. Then we have negative root 10 times 7, which makes a negative 7 root 10. Good. And then negative root 10 times positive root 10. Be a negative 10. Okay, and so the roots should cancel out, and they do, correct? And so we end up with 49 minus 10, which is what? 39. Okay, now we also need to distribute the top. Or actually, yeah. Well, I guess you don't have to. Maybe we shouldn't, and just see if we can reduce without distributing. So I'm going to rewrite this. So right now, for my numerator, I have 3 times 7 plus root 10. And then my denominator is what? 39. Okay. So the 3 and the 39 are not connected like glue with anything that's adding or subtracting. And so if you look at those, could we reduce them? Yeah. So 3 goes into both of them, correct? And so we can cancel out this 3, and then 3 goes into 39 how many times? 13. So we end up with 7 plus root 10 over 3.
13.
Thank you. 13. That's what I meant to say. Any questions there? Okay. So going to the next example, there's nothing I can add or combine or do anything. But the problem is that we have roots in the denominator. And so your answer can never end up having a root in the denominator. So in order to simplify this, we have to get rid of the roots in the denominator, which means we will multiply by what? The conjugate. And in this case, what is the conjugate? Very good. Root 3 minus root 5. And I always end up putting the other thing with plus or minuses in parentheses. And we know that whatever we do to the bottom, we also do to the top. And a y. Why is it that I do whatever I do to the bottom, I have to do the top? Because if you look here right now, these could actually cancel out, and all we're really multiplying by is what? Is 1. Okay? So now we're going to simplify. So, root 3 times root 3. Do we need to write that out? What is root 3 times root 3? 3. Okay? Then we have root 3 times negative root 5. What does that become? Negative root 15. Good. Okay, now I'm moving down here. Okay? And so we have root 5 times root 3. A positive root 5 times a positive root 3 makes what? Very good. A positive root 15. And then we have a positive root 5 times a negative root 5. Negative 5, right? And if we need to write that out because it's confusing, we can. But if you're able to kind of just distribute and go through, that also works. And what has happened here? These cancel, and that is the whole purpose. If the roots don't cancel out, you did something wrong. And so we're left with 3 minus 5, which is what? Negative 2. Okay, so we're going to go ahead and write this out just like we did the last time. And so now I have root 7 times root 3 minus root 5 all over negative 2. can I reduce anything like this? No. So we're going to distribute, okay? And this way we can see if we can get any groups and can simplify or do anything. So root 7 times root 3, would I be able to make any pairs from that? No. So what's that just going to become? Root 21. Okay, or yeah, root 7 times 3, so we multiply the 7 to 3, get root 21. Okay, now for root 7 times negative root 5, would I get any pairs for that one? Nope, so we're just going to multiply it. We get negative root 35, and this is all over, negative 2. And again, there's nothing that I can simplify or do, so this is my answer. Okay. All right, so we have this last one. This one is slightly more complicated, and do you know why? Yeah, and if you notice on the top, prior we just had like a monomial, one single term, and on this one we have a binomial, we have 2 terms. Okay, and so again, we have to, can I like eliminate these root 8s? No, because why? Because they're connected, right? Because of the plus or minuses, they're all stuck together, correct? And so I can't reduce anything, and so now I'm just going to have to multiply by what? Close. The conjugate would be I'd multiply by, very good, 2 plus 5 root 8. And so because we have a binomial times a binomial, we have to do the distributing to both the top and to the bottom. Okay? So we're going to start, though, with our denominator. Okay? So we have 2 times 2, which is what? 4. Okay, I'm going to write out the next part if you want me to. I don't know. So we have 2 times 5 root 8. Okay? So hold on, I'm going to write this. 2 times 5 root 8.
Why is it 10?
When we're distributing, we're multiplying everything.
Oh.
Okay? So 2 times 5 is 10, but could root 8 break down? Do you think I should break it down? No, why not? Does it need, you're right, I shouldn't, but there's like a reason why I shouldn't. Well, we could break down the 8 and you would have 2 times 2 times 2 and we'd have a pair of 2s. And so we could do that, but what's always happening with our root terms? They're canceling out. So we could break this down if we want to, but it's just wasting our time because they're going to cancel out anyways. Am I making any sense?
Oh, yeah.
Okay, so I just want to show you that for a second. All right, so now I have 4 plus 10 root 8, okay? The 2 times the 2 made the 4, okay? 2 times 5 root 8 made 10 root 8. Are we good there? So now we're going to the second term. Negative 5 root 8 times 2 is negative 10 root 8. And then negative 5 root 8 times positive 5 root 8. What's that going to make? You're right. But I don't know if everyone else is figuring it out yet. So we would end up with negative 5 times 5. And if you need to, we can write this out. Negative 5 times 5 is what? Negative 25. And then you have root 8 times 8, correct? So we have a pair of 8s. So we end up with negative 25 times 8, which is what? Negative 200. You have 8 quarters. You have 8 25s. Okay? Are we good there? Okay. So again, our roots cancel out. And we have 4 minus 200, which makes what? Negative 196. Okay, so right now, my denominator is negative 196, and the numerator is 3 plus root 8 times 2 plus 5 root 8. So what do we need to do now? Multiply the numerator. Okay? I'm going to give you guys a chance to do that one on your own. Are the middle terms on this one going to cancel out? No. So you might want to simplify those more. And actually, you know what? I'm looking at the time. We're going to go ahead and do this together for time's sake. Okay? But I'm going to pull some 6, have you help me. So, first one that we're distributing, okay, and multiplying. She's not here. Haley. Okay, what am I going to do first? Three times 2. And what is that? Good. You looked out there, huh? Okay, nicely done. Okay, next, what am I going to multiply? Raylan. That's kind of funny. Okay, go ahead.
2 times 5.
No.
Or I mean 3 times 5.
Very good.
Sorry.
And how would you write that out?
15.
Good, 15 root 8. Okay, now you have 2 options. Like right now, I might go ahead and break this down and simplify it. So what does 8 break down to be? 2 times 2 times 2. So I have a pair of 2's and a 2 left over. So this actually becomes what? Very good. 30 root 2. I'm going to go ahead and write this 6 again too. Are we good? Okay. Next, what am I going to multiply, Emily? Close. We're going to go to the 2 first. We're going to go root 8 times 2. Is that okay? And so what would you get there? To start with. Don't, just write it first as 2 root 8, and then good. Then I would simplify, and so 8 breaks down to what? 2, 2, and 2, which gives us a, very good, ends up as 4 root 2. Nicely done. Okay, and next, please help me. What would you do with this Trini?
So root 8 times 5 root 8.
Good, and that would first make what?
That would first make 5 root 8 times 8.
Good.
Which would be 40.
Very good, because you get a pair, and you get 5 times 8, which is 40. Nicely done. Okay, so now that we have all this, I'd like somebody to help me out with, are there like terms that I can combine together? So Marina, are there like terms I can combine together? Okay, so like terms, like you see how 60 and 40? Okay, so that would make what? Very good, 46. Are these like terms? Yeah, because they both are with root 2's, right? And so we can add them together, and so what would those become when you add them together? Very good, 34 root 2. And this is all over negative 196. Now, looking at this, can I reduce at all? So, because you have like these 2 terms that are connected like glue, right? And then you have this negative 196, you would have to be able to divide all of them by the same number. Is there any number that would go into all 3 of those numbers? 2. Good. So we can reduce every single term by 2. So when we do that, we're dividing by 2. This makes this a 23. Dividing this by 2, it makes it a, good. And then dividing this by 2 makes it negative, very nice, negative 98, yeah. Okay, so we get 23 plus 17 root 2 over negative 98. Okay. Any questions? All right. Last 2 problems. Okay. So here it's asking us to find the perimeter and the area of the rectangle. Okay? First of all, because it's a rectangle, what do we know? Very good. Rectangles have congruent sides, correct? And so if the bottom here is 5 root 2 plus 7, that means the top is 5 root 2 plus 7. And again, because we know this is a rectangle, if this left side is 4 root 3 minus 2, over here, this is also 4 root 3 minus 2. Who remembers how to find perimeter? Good. And so we'll just make a note in case, I don't know. Perimeter, add all sides. So it is important that you have the information for all the sides before you actually add all the sides. So it's good to write everything in. Okay, normally we always put our real part first. So if you wanted to, we could write all these out, each one of the sides. Do you guys want to take the time to write all of them out? No. Me either. So let's just go through and add them. Does that sound good? Okay, so I'm going to start with all of my whole numbers. I have a negative 2, I have a positive 7. When I add that together, it makes what? 5. And then 5 minus 2 is 3, and 3 plus 7 makes 10. So all I did was add all the numbers without roots together. Okay? We could have also done negative 2 plus 7, which is 5, and then we knew the other 2 would make 5, and 5 plus 5 is 10. Okay. Are we all good there? Okay. So the next, I noticed that this is a root 3, and this is a, can I add those together? No. But can I add this 4 root 3 and this 4 root 3 together? And that makes how much? 8 root 3. Okay, so we can only add the front numbers together, and we can only add them if they have the same roots. And then I can add the 5 root 2 and the 5 root 2 together, which makes a 10 root 2. And there's nothing more I can do because I can't break down these roots at all. And so this is my perimeter. Do we have any questions? Okay, area. How do I find area? Very good. You multiply your length times width. So on this one, what will I end up multiplying? Perfect. 5 root 2 plus 7 times 4 root 3 minus 2. It doesn't matter which way I wrote that. No, you could have flipped it around and wrote 4 root 3 minus 2 times 5 root 2 plus 7, either way. Okay, so now we have to multiply, which is what we've been doing this whole time, correct? So we're going to distribute. 5 root 2 times 4 root 3. So, good. So we're going to multiply the 5 and the 4 together, which makes 20, root 2 and 3. Am I going to be able to get any pairs from that? So I'm just going to multiply them together and get 6. And again, if you want to write this out to the side to help you out, you can. Okay? Next, I have 5 root 2 times negative 2. So remember, very good, negative 10 root 2. You multiply numbers that are not under roots together and then the roots together. Okay, so since there's no root with this one, you just multiply it with the 5. Okay, moving now to the next term, 7 times 4 root 3 will make what? Very good, 28 root 3. And then we have 7 times negative 2, which is what? Negative 14. Are there any like terms anywhere in here that I can add together? Is there anything I can break down and make it something else? No. So this is my final answer. Okay. All right, next one. Are you ready? Well, So, for instance here, if you have a specific area, you know the area of what you have, and you know one of the sides is something like this, you can find out your missing lengths. It's mainly for like building, and you'll find that measurements are not always exact, and so we're dealing with non-exact measurements. Okay, so they put question marks here. This is what's missing. We need to find the unknown side. I am going to just give this an X instead of writing it as question marks because I think that's easier to deal with. Again, we find area by doing what? Length times width. Okay, so we would write this as X times root 11 plus 2 equals, and what is the area equal to? 7. Okay, so if we're solving for the missing side, that means we want to get what by itself? X. This is set up nicely to get X by itself. What would I do? Very good. You would divide by root 11 plus 2 to both sides. Okay, and so I do that, and X is now by itself, which is just wonderful. Okay, but what is not wonderful? There is a root in the denominator. Okay, and so how are we going to get rid of that root in the denominator? We are going to multiply by the conjugate. You guys are so smart. And what is that conjugate? Very good. Root 11 minus 2. And whatever we do to the bottom, we also have to do to the top. Okay. So, you guys ready? Okay. Root 11 times root 11 equals what? 11. Right? Okay. Root 11 times negative 2 is? Good. Positive 2 times root 11 is? Very good. And positive 2 times negative 2 makes a? Negative 4. And when we're multiplying by the conjugate, what should always be eliminated? The roots. And do these eliminate? And what is 11 minus 4? 7. So my denominator is 7, and I'm going to go ahead and rewrite the top, which is 7 times root 11 minus 2. Is there anything that can eliminate here? The 7s. And so my answer is what? Root 11 minus 2. So question mark, question mark, question mark equals root 11 minus 2. You're right, it is a square, but they didn't tell us what it was.